Hello everyone. In the previous video, we had seen how scatter diagrams are drawn, and we had also seen some of the different types of scatter diagrams. How a scatter diagram will look like for a positive correlation, negative correlation, perfect positive, perfect negative. We had also seen how you say two variables are uncorrelated, how that scatter diagram will look like, and also we had seen curvilinear type of scatter diagram. So in this video, we first will see about the limitations in scatter diagrams. Of course, since we are drawing scatter diagrams using x-axis and y-axis, so scatter plot is possible only if it is two variables. Not for more than two variables, scatter diagram is not possible. Further, scatter diagrams, you can't exactly say what is the extent of correlation. Means whether the correlation is positively correlated to the extent of 80% or negatively correlated to the extent of 43%. Whatever it is, you cannot say exactly the extent of it. So you can only say whether it is positively correlated or negatively correlated or associated or dissociated, that much only. So it gives only an approximate idea of the relationship. Means it is only a qualitative expression of a quantitative change. So another thing is you need to have sufficient data to draw or see anything from the scatter diagram. With the limited number of data, you will not be able to properly get any information from the scatter diagram. Means even there should be a minimum data required, may probably like 100 pairs of data, 200 pairs of data you should have, so that much of plots will be there and which can able to depict what type of correlation that particular data is having. So these are some of the limitations. So in order to overcome these limitations, the mathematicians that time or statisticians that time felt the importance of having a measure. So Karl Pearson brought in a measure called product moment correlation coefficient, so which he denoted it by smaller r and defined as covariance of x comma y divided by the product of standard deviations. So where Vxy is covariance between x and y, sigma x is standard deviation of variable x, sigma y is standard deviation of variable y. So what is covariance? It is nothing but summation x minus x bar multiplied by y minus y bar, the whole thing divided by n, where n is the number of pairs of data. X bar, of course, it is arithmetic mean of variable x, which is nothing but summation of x by n. Y bar is arithmetic mean of variable y, which is, sorry, here I should have mentioned it as, it should be y. Yeah. Sorry. And standard deviation is nothing but summation of x minus x bar the whole square by n, the whole thing the square root. Similarly is the standard deviation of y. And if I start substituting in this formula, means covariance by standard deviations, product of standard deviations, we already have covariance formula like this. Then we know what is x bar formula. We also know what is standard deviation formula. Substituting all these things, I will get the revised formula for R as n times summation x into y minus sum x into sum y, the whole thing divided by n times summation x square minus sum x the whole square, the whole thing multiplied by n summation y square minus sum y the whole square. What are the properties of correlation? First of all, it is an unit-free measure, means if one variable is of one particular measure or unit, the other variable is something else, other unit. Like for example, here I specified height in centimeter and weight in kilogram. Still, I can find out the correlation between these two because it is unit-free measure. And correlation coefficient always lies between -1 and +1. So R lies between -1 and +1. So -1 less than or equal to R less than or equal to 1. The third property, it is independent of origin and dependent on scale. Means the data, if it is having a larger numbers, that numbers can be simplified by applying this property. X minus a, I can bring in a new variable as u, which is x minus a by b, a new variable v, which is y minus c by d, where a and c are the origins taken for x and y respectively, B and D, you call it as a scale taken for X and Y respectively. Then instead of finding out the correlation between X and Y, you can first find out what is correlation between U and V. Same formula will be there. In this formula, wherever X and Y is there, it will be substituted or replaced with U and V to get what is correlation between U and V. So that can be found after you find correlation between U and V. You can very well use this. That is, you can find out correlation between X and Y as modulus of B multiplied by modulus of T into correlation between U and V, whole thing divided by B into D, or this modulus can come to denominator and this B and D can go to numerator. Either way you can able to do it. So these are the three different properties of correlation coefficient. So that's about this particular video. In our subsequent videos, we will try to solve some problems on correlation coefficient. In the meantime, if you find this video to be useful, I request you to please like, share, and subscribe to my channel. Thank you.